attribute value can be stored. So that can be stored with the help of predicate, or that can be stored with the help of this type of structure. Okay, so we have a knowledge representation, we have a FOPL, we have a rule-based system, semantic net, frame-based system. We will discuss in block 2. We have a details of this FOPL. Okay, FOPL, semantic net, we'll discuss. Next, we are starting rule-based system. Okay, we'll discuss FOPL. FOPL is nothing but a predicate logic. Okay, so today we'll start this. This is the topic is today we'll start is a prepositional logic. Okay, after prepositional logic, it will continue with the FOPL, first order predicate logic. Okay, this is on block 1, third unit. So FOPL, we have a knowledge representation. We'll discuss later on after completion of a prepositional logic. Okay, because it is advance of prepositional logic. Next, we are starting rule-based system. Okay, rule-based system. So rule-based system, by the name we can understood. Rule-based system, it consists of a collection of rules. Collection of rule and its corresponding action. Okay, so rule-based system means basically it consists of a collection of rules and its corresponding operations. See, rule-based system architecture, it consists of a collection of rules, it consists of a collection of fact, and it consists of an inference engine. Okay, so collection of rules are there, collection of fact are there. Fact is nothing but a knowledge, and we have an inference engine. Inference engine means it can generate a new knowledge from the existing knowledge. It can generate a new knowledge from the existing knowledge. Okay, that is what a inference engine. So we might want to see what a new fact can be derived. So new fact can be derived using the inference engine. So inference engine can generate a new knowledge from the existing knowledge. So that's why in a knowledge base, actual data will be stored into the knowledge base, and from a knowledge base, inference engine will generate a new knowledge from the existing knowledge and asks whether the fact is implied by the knowledge base and already, or the fact is already known fact. See, detail of a rule-based system. Based on rule, but different knowledge base in a horn form. Knowledge-based system can be divided into rule-based. Rule-based means the collection of rules. Okay, working memory. Working memory means it is a working memory is basically it is a knowledge base where the collection of knowledge, collection of fact, collection of knowledge can be managed. Okay, so for example, some knowledge is not used, we can delete that or knowledge and we can store some new knowledge. Okay, so just like rule is like a special type of if then rule. Okay, so P1, P2, P3 up to Pn implies to A1, A2, A3 up to AK. So P1, P2, P3 up to Pn is a set of antecedent as a conjunction of conditions, and A1, A2, A3 up to AK is a sequence of actions. Okay, means as for the, for example, P1 and P2, A1. So that means if P1 and P2 is satisfied, so A1 will be executed. So there may be a rule. Okay, so that is basically a conjunction, the conjunction of condition and the consequence of action. So basic operation, check if the set of rules, antecedent of a rules is satisfied, decide whether which rule is executed, and execute action in the consequence in the rule. So this is basically the theory of rule-based system. This is a theory of rule-based system. Okay, we'll come on details of how rule-based system can be implemented in real life. So So I think what is rule-based system is clear. So rule-based system is a collection of rules which consist of a set of rules, and every rules having some condition and action. It may be used if then else. If rule one means rule one consists of some condition and some actions. Okay, where having a collection of fact and inference engine. So next is we have a two type of rule-based system. We have two type of rule-based system. I hope it is clear, or if you want to ask any question in between, you may ask. Okay. I'll discuss with one example of rule-based system. Okay. In one real life example, I basically I think I will take what a job problem is a classical problem. Okay, how that problem can be implemented with rule-based system, that I will discuss. In your book, several system is already discussed. Okay, I will discuss with a new problem with a what a job problem. Next, the types of rule-based system. Okay, types of rule-based system. So rule-based system is a two type. Okay, rule-based system is a two type. One is a forward chaining system. Okay, one is a forward chaining system, another is a backward chaining system. What is initial? Starting from the initial, reach to the goal state. Starting from the initial, we'll start from we have a search space. We have a search space, and we'll start from the initial phase using some intelligent agent. We are moving one by one, and finally we reach to the goal state. Okay, and that is known as a forward chaining system. Okay, so start with a fact and see what rule apply, and hence what should be done given the fact. So this forward chaining system, obviously it is a data driven techniques. Next is a backward chaining system. Most of my many real life problem comes with a backward chaining system. Backward chaining system is basically start with the goal state. Start with the goal state. I try to find out the initial state. Okay, so start with something to find out and look the rule that will help in answering. That is a goal driven. So back chaining is basically is a backward chaining. So we know the goal state. Okay, so we'll reverse from a goal state. We'll reverse back, and initial we want to find out the what is the initial state. Right. So many rule-based systems are forward chaining system. Many traditional system, for example, we are searching anything, searching a particular number. We have a search space in our tree. Okay. For example, we have a huge data set out there. Okay. So that data set in the form of tree, we want to search a particular element from that tree. Okay. So for that, obviously, the forward chaining technique is used. Okay, just I'm giving example. Just like assume we have some crawl data of a Facebook. We have some crawl data of a Facebook. Okay, so the Facebook data, obviously it is not the data of a RDBMS. It is a NoSQL data. Okay, so maybe data is a graph database. Whatever data is stored, that is a graph database. Okay, means database which form a graph. Okay, so which data set is not a normal data, is a big data. Is a big data. Data set is a big data. So in that data set, you want to try to find out some goal state. For example, you want to try to find out the sentiment of a particular user. So we have an initial state, and using some techniques, means we have a graph database of a Facebook data. So we try to find out some sentiments. Okay, so we'll start from initial and we'll go to the intermediate node, next node, and will finally reach to the goal state. Best example, just like in a searching, lots of searching technique is available in AI, is a BFS, breadth first search, DFS, depth first search, A asterisk search, AO search. Okay, there is a, so lots of that searching techniques are there. So just like a DFS, BFS, whatever we are using a basically a is a forward chaining system. Next is the backward chaining. Many cases backward chaining technique is used. Okay, we know the goal state. Just I'm giving example with the backward chaining is a real world example. For example, doctor. Okay, when a doctor check any patient, okay, patient will tell their goal state. For example, patient having a fever. Okay, patient having some problem. Okay, so patient tell the problem, and that problem is nothing but a goal state. And the role of a doctor is he will use his expert knowledge. He will use his experience and try to find out what is the initial reason of his disease. For example, assume one patient comes to a dermatologist, he having a eczema. Okay, so a doctor will try to find out what are the reason, means you'll get the goal state. Goal state is he got eczema. Okay, or any doctor get a goal state as a he having a fever. Okay, so doctor try to find out what is the reason, what are the what is the initial state of his disease. Okay, that is basically he use a backward chaining system. See, just like I'm giving an example, the rule 1, rule 2, rule 3, just like rule 1, if hot and smoky, then fire. If alarm beep, then it's smoky. If fire, then switch the sprinklers. Okay, F1, alarm beep, F2, hot. Okay, so we have a two fact is alarm beep and hot. Okay, we have a three rules, rule 1, rule 2, rule 3. If hot and smoky, then fire. If alarm beeps, then is smoky. If fire, then switch the spring kernels. See, in rule-based system, in forward chaining system, the condition and actions rules represent action to take when the specific fact occurs in main working memory. So this is the working memory, this is the inference engine, and this is the rule base. See, this is a user. Okay, so working memory where set of fact is stored, set of knowledge is stored. Rule base, the set of rule is stored. And inference engine is a component. Okay, basically in a knowledge based system having a three component. Okay, working memory, inference engine, and rule base. Okay, working memory is basically it is used to store fact, it is used to manipulate knowledge, it is used to add some new knowledge, it is used to modify some new knowledge, it is used to delete some knowledge. Okay, it is just a knowledge based. Okay, and rule based system, we have a set of rules. Okay, just in previous slide I have discussed R1 equal to this. That is a rule 1. So rule based system stores set of condition and action. Rule 1 consists of some condition and action. Rule 2, condition and actions. And what is the work of inference engine? Inference engine will read data from the working memory. Okay, it will means inference engine will read the knowledge that is a fact. It use the rule and apply and generate a new knowledge. Once again, I'm repeating. This is the external user. Okay, external user will interact with the working memory. Okay, he will feed the details in the working memory. And the rule-based system is basically a rule-based system having set of rules. Okay, and working of an inference engine from the existing rules, how a new rule can be derived, how new rule can be derived. So that is a basically a rule based system. I hope it is clear. Okay, for not only in rule based system, every symbolic system, the structure is more or less, means knowledge based system structure is this. Okay, in knowledge based system, knowledge is stored in a symbolic structure. Working memory can store the knowledge. So knowledge is stored as a symbolic structure, but in the form of a collection of, for example, in a computer, it's stored in the form of a magnetic spot and voltage state. Okay, so it can store knowledge. For example, in biology, okay, knowledge can be stored as a complex structure of interconnected neurons. Okay, so the structure correspond symbolic representation of a knowledge. Okay, for example, in biology, for example, knowledge is basically stored in a brain. Okay, brain consists of a set of neurons. Okay, so this is a set of rules and this is a set of fact. So backward chaining, already it is discussed. We know the goal state, and from the goal state we back. Okay, and we'll try to find out the initial state. We'll try to find out the initial state. This is a backward. We have a goal state and try to find out the same. Rule 1, rule 2, rule 3, fact, hot and alarm wave, and goal state means we are backing from the initial to goal to initial. Next, AI. AI having a different types of AI. So AI is a artificial intelligence is a type 1 and type 2. Okay, narrow AI, general AI, strong AI. Type 2 is a reactive machine, limited memory, theory of mind, and self-awareness. Okay, so first of all, type 1. Type 1 is basically, there is a 2 or 3 type of AI. One is a narrow AI, general AI, and strong AI. So first of all, what is narrow AI? Okay, what is narrow AI? Narrow AI is basically means it is divided into different categories. Okay, just I'm showing on the next slide. Yes, just like AI narrow intelligence, AI general intelligence, and AI super intelligence. Okay, so AI narrow intelligence, it is work in machine learning. Okay, which you have to study in block 3. Okay, machine learning, how machine will learn, how machine will train. So here in weak means AI narrow intelligence is called weak AI. Okay, weak AI is a term of thinking that is simulated. Okay, such system act intelligently, but they don't have any awareness of what they are doing. For example, the example is chatbot. Okay, chatbot is a means chatbot, you are talking, you might talk with the chatbot. Okay, but chatbot doesn't know you. Okay, so chatbot does not know who it is and why it is talking to you. Okay, so that is what a narrow. Next, AI in intelligent, that is an example is a machine intelligence. Okay, machine intelligence. So strong or general artificial intelligence is called actual thinking. Okay, so smart human and thinking like the consciousness, like a cognitive science, like a sentiment analysis, it is basically the machine intelligence. Okay, machine intelligence. And the third thing is basically AI super intelligent. So the term super intelligent usually refers to the level of general and strong. Okay, so AI that is smarter than human. Okay, AI can perform some automatic operation. Okay, so it can perform a different step like a humans. okay, which having make a set of decision based, which is a decision support system. That is basically a uh, the AI machine consciousness. Okay, machine consciousness. Next, the component of AI, learning. Learning. So there are the numerous approach to develop a learning system. In AI, machine learning is nothing but it is not different from AI. Basically, it is a sub part of AI. Okay, where we are using different techniques of learning. Any data set, we are dividing the data set into training data and testing data. Okay, we are using different techniques of a learning, how machine will learn automatically. Okay, so just for example, you are taking some mistakes, and from mistake you learn something. For example, traffic signal was there, but uh, by mistake you have not followed that, and traffic have given you some penalty. Okay, so from penalty we learn something. Okay, that is what a learning means. Basically, from anywhere we are learning. Next, what are the types of learning? What are the types of learning? Is rote learning, learning by instructions, learning by analogy, learning by inductions, learning by deduction. So these are the different form of a learning. So first is rote learning. So rote learning is the simplest method of learning since it involves the least amount of interpretation. So information is simply copied into database. In this method is of learning. This technique is just like memorizing multiplication table. Okay, it's a simplest form of learning. Just we memorize. Okay. Next, learning by instruction. Whatever the instruction is given. So the next method of learning, that is being instructed, means we have a lots of data. Okay, will not take. Okay, will take those which is instructed. Okay, because new knowledge must be contributed to an existing knowledge base in order to be useful, and this type of learning necessitates great inference. Okay, just like when a teacher instructs a student, this is a type of learning occur. That is the learning by a instruction. Next, learning by a analogy. Okay, analogy is basically just like when you are learned by analogy, you generate a new idea by connecting previous learned concept. Just like you have studied textbooks, frequently employed this method of instruction. Okay, so that is basically a learning by analogy. Next, learning by induction. So learning through a induction is the most common method of learning. This is method, this method of learning that employs inductive reasoning. That is a style of reasoning that involve drawing a conclusion from a large number of instances. Means we have a lots of uh, output. From the lots of output we got certain conclusion, and that conclusion is basically a learning by induction. So these are the types of learning. Okay, and we'll discuss detail what are the types of learning in machine learning. Next, AI, ML, and deep learning. What is the difference between AI, ML, and deep learning? So AI is a branch of computer science that deals with the symbolic rather than the numeric processing, rather than the numeric processing and non-algorithmic method, including the rules of thumb or heuristic instead of algorithms as a technique for solving the problem. So this is what AI in simple terms, AI is a branch of computer science that dealing with the symbolic programming. It does not deal with the algorithmic method. Next, what is machine learning? Okay, machine learning is learning from experience. So machine learning is basically a study or process which provide the system to learn automatically on its own through experience, it had and improve according to the explicitly program. Means for example, we have a huge data set. Okay, from the, for example, we have a historical data set. From that historical data set, we learn some experience, and that is basically a machine learning, learning from the experience. Next, the method is a deep learning. Okay, all are the branch of machine learning, deep learning, all are the branch of CS, computer science. So deep learning is a subset of machine learning. It is a subset of machine learning, just like machine learning is a subset of AI. So deep learning is a subset of machine learning that uses multi-layer neural network. It's called deep neural network to simulate the complex decision-making power of the human brain. Okay, so deep learning is basically, I think you have an idea about a neural network. In a neural network, only one layer is used. In a deep learning, multiple layers is used. Okay, which is widely used for many type of complex problem, AI problem. Okay, the deep learning techniques. Nowadays, lots of research problem, we use a machine learning and deep learning. Okay, so if we want to differentiate AI is basically a symbolic programming. AI provide a framework. So obviously, machine learning is also a part of AI. AI is machine learning is not a different, but machine learning is a specific use a specific algorithm. It having a huge number of algorithm. So machine learning, ML stand for machine learning. That is a study that uses statistical method enabling the machine to improve the experience. And deep learning is basically is a study that make use of neural network to imitate the functionality just like a human brain. Okay, AI is a broad family consists of a ML and DL. ML is a subset of AI and DL is a subset of ML. So machine learning can be used in many problems, but deep learning is used for a very complex problem where multi-layer approach is there. See, this is AI is a branch. Already you have studied what is AI. Okay, so part of our AI is machine learning, and the part of a machine learning is deep learning. Okay, and we have in machine learning is also divided into supervised learning, unsupervised learning, reinforcement learning, and semi-supervised learning. Okay, we'll come in details in block 3. In a machine learning, we'll firstly start with what is supervised learning, what are the algorithm of supervised learning, what is unsupervised learning. For example, decision tree, many methods are there. Next, AI and robotics. Okay, so AI is widely used for nowadays training, early detection of disease, diagnosis, decision making, decision support system, treatment, end of life care, research and training. Okay, so artificial intelligence right now is widely used in different sectors, just like healthcare, agriculture, smart mobility, retail, manufacturing, energy, smart cities, education and skilling, and financial industry. So healthcare. So healthcare is one of the field of AI where many medical science people are widely working. Okay, mostly the AI is used by the medical science people for predictive analysis. Okay, predictive analysis for in order to prediction. Okay, in order to predictions that can be used. So in healthcare, the application of AI in healthcare can help the address issue of high barriers to access the healthcare facility, particularly in rural area, and or suffer from a poor connectivity and limited supply of a health profession. Okay, so AI driven different method is developed AI driven diagnostic, personalized treatment, early diagnosis of any diseases, okay, or any diagnosis or any type of prediction, okay, which helps the patient, okay, the early detection of diseases, okay, just like we know many patients detect their cancer at the last stage. In that time it is very basically a very too late, okay, for their improvement. But if that is identified at the earlier age, that will be a more better, that become a more better. So next, AI can be used with agriculture. AI can be used with agriculture. So AI has potentially to bring a food revolution while simultaneously satisfying ever increasing need of the food. Okay, so AI can give a different type of how uh, the agricultural facility can be improved. Okay, so that means it is also having a ability to resolve issues such as a uh, inadequate demand predictions, okay, lack of secure irrigations, okay, like the misuse of pesticide or and fertilizer. So these are the means how the crop increase of crop, okay, it is with the diversible situations. So these are the technique is used in AI. So AI can be used for smart mobility, just like including transport and logistic. So autonomous fleets for ride sharing, semi-autonomous features such as a driver assistance and predictive engineering monitoring and maintenance are all possible use cases for smart mobility. Okay, so retail sector. So retail industry was one of the first to use the AI solution. For example, the personalized suggestion, browsing based on user preferences. Okay, nowadays in most of the many software is also AI based. It can detect their error automatically. So manufacturing cases, manufacturing sector also AI is used. So AI based solution are expected to help the manufacturing industry the most. So it's a factory of the futures, just like how manufacture industry can take the help of AI to improve their manufacturing. Next is energy. If the energy sector possible use cases including modeling and forecasting energy system to make it less unpredictable and make balancing and using power more efficient. Okay, just like a renewable energy system. So AI can help to store energy through a smart meters and intelligent grid. Smart cities. So integrating AI into newly built smart cities and infrastructure could also help meet the need of populations, and that is moving the cities quickly and improve the quality of lifestyle of those people. In education, AI is widely used. Okay, so quality and access problem in the education sector might be a fixed by AI. So possible use of adding and improving the learning experience. Next, financial industry. In the finance industry, they use a AI. Okay, for example, to find out different type of banking sector problem, just like fraud detections. Try to identify what are the problems are there. So top application of AI. So top used application in AI tools and checker for plagiarism. We know any research paper. Okay, before publishing, we'll check the plagiarism. Okay, lots of plagiarism software is available, but most of the plagiarism software is a chargeable, and it can provide a better means it is provide a better secure system. So different AI based tools checker for plagiarism. Okay, so it can for example you have idea like a paraphrasing software. Okay, paraphrasing software that use the concept of AI recognizing faces, putting AI autopilot on commercial planes, autopilot application for sharing rides, Ubers, okay, email spam filtering, Google prediction system, okay, predicting, protesting against stopping fraud, smart personal assistant like Alexa. So these are the places where AI is used. Next, intelligent agent. Intelligent agent. So agent may be thought as an entity that act and generally on behalf of someone else. More precisely, agent is an entity that pre-receive the environment through the sensor and act on the environment through a actuators. So some expert in the field require an agent to be additionally autonomous and goal directed also. So that means we can develop an AI-based system where multiple intelligent agent is nothing but it is an object. So the percept may be bought as an input to the agent through its sensor over a unit of time sufficient enough to make some sense from the input. Next, percept sequence. The sequence of percepts generally long enough to allow the agent to initiate some actions. So agent can be anything. So what is software agent? A software agent is a system which and when given to on a goal to be achieved would carry out the details of the appropriate operation and further. And in case it gets struck, it can ask for advice and can receive from his human, may even evaluate appropriate of the advice and act suitability. So that means what is software agent? Next, it has an autonomous control. So that means it operates under its own control. It is a perceptive. So that means capable of perceiving its own environment. It persists over a long period of time. Next, it is adaptive to change in environment, and it is capable of thinking over other goals. That is an intelligent agent. Next, what are the properties of agent? It should be reactivity, it should be autonomy, it should be communication facility, ability to consist of a cooperation by corporations, ability to adapt a new simulation, ability to add means ability to draw inference, temporary continuity, personality, and mobility. So these are the properties of agent. This is what agent. Agent means it is an entity. Agent means it is an entity. We will basically maybe using sensor, using IoT device we are using. Okay, that can be agent. Agent can be anything. We are coming on details. This is the properties of entity. Next, example of agent. Simple reflex SR agent. Simple reflex SR agent. So these are the means we have a various type of agent, just like SR agent, that is a simple reflex agent, model based reflex agent, goal based agent, utility based agent, stimulus response agent, or learning agent. So first of all, what is SR agent? So these are the agent or machine that have no internal state and simply react to the current perceives in their environment. An interesting set of agent can be built. The behavior of the agent in which can be captured in the form of a simple set of functions and sensor input. So here it is showing with a diagram of a SR agent. So this is the SR agent, simple reflexive SR agent. The next is a model-based agent. It is a model-based agent. So model-based agent is simple reflex agent are not capable of handling a task environment that is not fully observable. In order to handle such environment properly, in addition to reflex capabilities, the agent should maintain some sort of internal state in the form of a function of the sequence of perception. Okay, so that is basically the model based reflex agent. The next is a goal based. We have an initial state, we have a goal state. Okay, so the goals, goal state. So in a goal state, in order to design an appropriate agent for a particular type of task, we know the nature of the task environment play an important role. Okay, so it is desirable that the complexity of the agent should be minimum and just sufficient to handle the task in a particular environment. Okay, so this is what a goal based agent. Next, solving problem. We are coming to the solving problem. So solving problem is basically define the problem precisely and find the initial and final configuration of the applicable solution to the problem. Analyze the problem, find few important features that may have impact on the appropriate of various possible techniques for solving the problem. The next is isolate and represent task knowledge necessary to solve the problem. And the last is choose the best product, simply techniques, and apply to a particular problem. So this is what how problem. Okay, next, how the problem can be formulated. How the problem can be solved. So define the state space. State space means basically the space, okay, where we can put it. So define a state space that contain all the possible configuration of the relevant object. Define set of state that describe the possible situation from which the problem solving process may start. That can be called as an initial. Specify one or more than one goal state. One or more goal state defining set of rules for the actions that can be taken. So this is nothing but how to formulate it. Okay, how to formulate it, how to identify it. So next is problem space. Problem space is, for example, for example, just like is a graph. Okay, for example, is a tree, is a problem space. So the problem space is represented by a directed graph. Okay, where the nodes represent a search state and the path represent the operator applied to change the state. Just go through this. Yes, the problem space. Problem space is basically the search space. Okay, that to be identified. Okay, so what is the search space? Okay, so means from where we'll search it. Okay, so the problem space must be defined. Okay, so problem space means it is a representation of a direct graph where the node represent a search state and path represent the operators applied to change the state. Okay, just like we have a graph. Okay, we have a graph where is a connected and directed graph is there. So graph having a problem state where multiple operation are there. Okay, we can change from one state to another state. So here in a problem space, we'll start from the initial state and we'll add any operator and we'll move to the next state. Again, perform some operation, we move to the next state. Again, perform some operation, move to the next state. So here, see, one is the initial state in a green color and another is a goal state. Okay, so the problem space, before an AI problem can be solved, it must be represented as a state space, where the state means the representation of an element in a given movement. So among all the problem state, there is a two spatial state is called initial state and goal state. Okay, the successive function is used to change the state. So it is used to move from one state to another state. A state space is the set of state reachable from the initial state. Okay, so just it is formulated. So we have a set of stated, and this is what a initial stated, and this is what a goal stated. So I hope it is clear. Next, we have a classic problem of a AI. Okay, one of the problem is a 8 puzzle problem. Okay, is one of the classic problem of a AI, 8 puzzle problem. Okay, so initial state, some configuration of the 8 tiles on a 9-bell board. Okay, it is designed just like this. Okay, initial state is this. So the operator is basically, there is a 4 operator is there, up, down, left, right. Okay, so goal state is basically, the goal state is clear, is the tiles in a specific order, means set of numeric number are there. So it was not arranged, you have to arrange. And how to arrange? By moving the slides. Okay, So it is a movable, and there is a four type of operator are there: up, down, uh, up, down. There is a left, right. Okay, these are the four operator are there: left, down, up, down, left, right. So this is what our initial state is: 1, 2, 3, 4, 5, 6, 7, 8. See, this is a problem. There is a starting state. We have a different other stated where we use a up, down, left, right. Means we use a set of operator in different state, and finally we reach the goal state. Okay, maybe it is not a one level. It will be a maybe a 3 or 4 levels. Okay, so there will be some initial state, and using arrow we are moving the transition from the initial state to another state. Okay, and for moving from one state to another state we use a operator. Okay, just like here operator is left, right, down, left, right, up, down. Okay, so is a up, down, left, right, and finally we'll got the goal state. See, this is basically the start state phase, and this is the initial and goal state. Okay, we have an initial, and we'll try to reach the goal state. Okay, and this is a problem solving techniques. Next, I'm discussing a new problem, is a new classic problem of a AI, is water jog problem. So what is water jog problem? So the state phase representation of a water jog problem. So water jog problem is basically we have a two jug. Jug is basically just like it is a container of water. Okay, so there is no level on it. Okay, there is no level on it. There is a in a two jug. There is a two jug. Just a minute. So there is in a two jug, one jug having a 4 gallon and another jug having a 3 gallons, both of which do not have measuring indication on this. One having a 4 gallons and another having a, so two jug 4 gallons and 3 gallons, both of which do not have measuring indication on them. The jug can be filled with water with the help of pump that is available. Just it is showing one means we can fill the water. Okay. Next question is, how can you get exactly 2 gallon of water into a 4 gallon jug? Okay, we don't have a measuring level, so we need a 2 gallons of water. That is where is the 4 gallon is stored. Okay, how to do that? So for that, basically we use a concept of rule-based system. Rule-based system consists of a set of rules and set of condition and their actions. Okay, so first of all we are identify what are the rules are there. So we have a 3 gallons and 4 gallons. The state space or production rules of this problem can be identified. Problem can be defined as a collection of order pair of integer, just like x and y. We have taken a two integer. X value is maximum is 4. Okay, so that means the value of x is 0, 1, 2, 3. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4 means gallon can have a zero value. Water can have a 1 liter of water, 2 liter of water, 3 liter of water, and 4 liter of water, and another jug having a 0, 1, 2, 3. So in the order pair, xy, x is the amount of water in a 4 gallon jug, y is the amount of water in 3 gallon jug. So the start phase all possible combination of x and y. So such state is 0 0. Okay, we'll start with a 0 0 value. So goal state is 2 comma n, and where the value of n is 0 1 2 3. Okay, so this is the explanation of the problem. Next, how to solve the problem. So to solve the problem, obviously you have to write a rule. Okay, so first is rule 1, x comma y, that is x less than 4, that is 4 comma y. So that means fill the 4 gallons jug. 4 gallons jug. Next, R2, x comma y, y less than 3. So x comma 3. The next is R3, x comma y. If the value of x is more than 0 and 0 y, so that means 4 gallon jug is empty. Okay. Next, rule 4, x comma y, that is y more than 0, x 0. So now the fourth rule is basically we are empty the 3 gallon jug, and third rule is we are empty the 4 gallon jug. Next, R5, pour water from a 3 gallon jugs into 4 gallon jugs until 4 gallon jug is full. So x plus y less than equal to 4 and y equal to more than 0, that is 4 and y minus 4 minus x. Next, rule 5, x comma y, x plus y is more than 3 and x more than 0. So that means x minus 3 minus y comma y 3. So that is basically where rule 6. So similarly, rule 7 is basically fill the all water from 3rd gallon jugs into a 4 gallon jug. This is the equation. Next, same operation from 3 gallon jugs into a 4 gallon jugs. R9, pour small water, some water D from 4 gallon jug. Next is R10. R10 is basically a pour some water out of from a 3 gallon jugs. So these are the rule is defined. Rule 1, rule 2, rule 3, rule 4 and rule 5. These are the rule is defined. Next, how to apply this rule? See, first initial state, both the jug is does not have any water, so that is water 0 0. Okay, so first is we apply the rule 1. We apply the rule 1, that is fill 4 gallon jug, that is the value will be there 4 comma 0. Okay, the next is we have a R6. We are applied R6, that is pure all water from 4 gallon jug into a 3 gallon jugs. So that means we are transferring all the water from 4 gallon to a 3 gallons. So 4 gallons to a 3 gallon means 3 gallon having a maximum capacity is 3. So that means up to 3 it will take. So that's why I've written 3 and 4 liter jugs. Obviously, and the empty will be there. That is a 1 liter. 1 gallon. Next, R6, empty 3 gallon jug. So that means 1 0. Next, R8, pour water from 4 to 3. Okay, 4 to 3. So that means 4 to 3 means basically it will be a 0, it will be a 1. Next is R1, fill that is rule 1, fill 4 gallon jugs. Next, R6, pour water from a 4 gallon jugs to a 3 gallon jugs until it is full. So that means 2, 3. Next, empty 3-gallon jugs. That means 0. So 2, 0. Our aim was is to make a 2, 0. Okay, means 4-gallon jugs. In a 4-gallon jug, 2 liter will be stored. So this is what a water jug problem. I hope it is clear. You may use another logic. This is another logic. There is a solution to. So this type of problem can be solved using AI. Okay. So the knowledge representation already we have covered today. Rule-based system. We have not started with the FOPL, first order predicate logic. So we are starting. Yes. Prepositional logic. Prepositional logic. So there are number of possible system of logic. Okay, prepositional logic. So prepositional logic is basically there are number of possible system of logic. The system we have been examining so far is called prepositional logic. The language that is used to express the prepositional logic is called prepositional calculus. So a logical system that can be defined in terms of a syntax and its semantics and set of rules of deduction that enables us to derive one expression from a set of other expression from and thus making arguments and proofs. So that means basically a logic is basically a set of statement. Okay, set of statement, and that set of statement can be added with a different syntax. So syntax is basically we have a symbol. Okay, we use this summation symbol. We use this the symbol of not, symbol of implies to, symbol of or. Okay, we have lots of symbol is used. Next, WFF, well-formed formula. So well-formed formula is basically the formula which is true under any cases. Okay, so that means WFF is a formula in short, the prepositional logic. Prepositional logic. So that means it is true under any circumstances. Okay, so atom is WFF. If A is WFF, then A naught is also WFF. Okay, if A and B are WFF, then A and B will be your WFF. A or B is also WFF. A implies to B is also WFF. A bidirectional B is also WFF. So any WFF is obtained from only by applying the above rules. So in a prepositional logic, we use different symbol. This caret symbol is used for a conjunction. This or symbol is used for disjunction. This implies symbol is used for implication. There is a conditional, and this bidirectional is a conditional is used for a equivalence, and literal, the atomic sentences or neglected atomic sentences, just like P not P. So P and Q implies to R. Okay. For example, the P having a meaning is it is hot. Q having a meaning is it is humid. So if it is hot and humid, then it is raining. So that is P and Q implies to R. So similarly, Q implies to P, Q So this is the truth table. So this is what a prepositional logic. In next class we will start with FOPL, first order predicate logic, because we have a left is for AI. We have a topic is knowledge representation. Today we'll discuss only one representation. It's a rule based system. Okay, and I have discussed with one example of a water jug problem, and we have started with a prepositional logic, and we have discussed. Anyone wants to ask any question? Yes, student. Anyone wants to ask any question, any doubts? No. Okay, that's all for this class. And the next class will be on tomorrow, same timing.